Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in this video, we are going to be comparing the Main PCB schematic version 3, which is this one here on the left. You can see the file name there is V3, with the version 4 on the right. And I was looking at this before I started recording, and I had written Q4 on this. You can ignore that. This RPTC-Q4. I really don't remember what that means. I know what the Q stands for, but not the 4. So anyway, in case you're wondering what RPTC-Q stands for, it stands for Remote Programmable Temperature Controller. -Q is for barbecue. Okay, so anyway, I was kind of looking at this and trying to figure out where to start, so I think I'll just start from the upper left-hand corner, and I'm going to go through this pretty quickly. There's not a lot of changes, but I figured, everyone would be interested that's following along. So look at the rotary encoder section here. And as you can see, I don't think anything has changed. You got the encoder, ground, some pull-up resistors, the 3.3 volts. Yeah, it's it's pretty much identical. So instead of repeating, I think I've talked about this circuit in a previous video. You can go look at that video and watch it if you want to see how it works. It'll be the schematic when I'm talking about the version 3 schematic. I did a couple videos and talked about all this stuff. And but anyway, this, in case you're wondering, this is a push button plus a rotary encoder. So when you push the button, it pulls up the main menu. And I believe this is the button circuitry. Yeah, rotary encoder PB stands for push button. And then rotary encoder A and rotary encoder B, so you can tell which direction it's turning. And that's pretty much it. And there's some, some resistors, and these are all pull-ups here. And I think these are just, this RC filter right here, just to kind of smooth it out a bit, right? So anyway, that's that. And we're going to go down here to the triac control section. These are going to have, well, it looks like just a transistor right there. So yeah, and I'm guessing that's, I don't think I changed anything. This has been pretty solid since day one, and it's a fairly simple circuit. So anyway, you got auger control, igniter control, fan control, and the spare. That's what SP stands for. And this is just a 5-volt pull-up, and then that goes off board to the high voltage board. Okay, and ISO 3 stands for the ISO optolator or optocoupler, which is on the high voltage board. We'll look at in another video. Okay, yeah, this is nothing real special. So let's see here. I don't think anything has changed. This is the ESP32, which is a system in package module, is what Espressive calls it. It's a system on a chip or a SoC. And ESP32 Pico D4. And this is basically just a couple headers on the main PCB. And this is how it's pinned out. Comparing it to the version 4 over here, I don't see any changes at all. I don't remember changing anything on this. It worked pretty good. Let's move this over a bit. Nope, they look identical. All right. So now this is where it's changed down here. These off-board connection headers down here. As you can see, I used to have a bunch of just dead pins that are just not connected. And this was going to the high voltage board. These are the pins going to the ISO optocouplers. And these off-board connectors here are going to the button panel. And you can see some of the not disconnected pins, or I should say not connected pins. And on version 4, I changed that. I either grounded the pins or put 5 volts on them, or both. So and you can kind of look at them. I think I also, like on header 2 right here, I moved them around to make it route the PCB routing a little bit easier. Header 1 didn't change any. Header 4, but yeah, so and this is where, if you were watching following along, and I had to put a bodge wire in for some grounding. Now I went ahead and just provided grounding everywhere. And some of you that are into the electronics thing might say, well, what about ground looping? And that's a good question. But in the art of electronics, I think I talked about it in another video. I don't have the book with me right now. But they said when you're doing board-to-board connectors like this, and especially if it's a low frequency stuff like this right here, these things are super slow. They said the main focus should be on reducing the impedance and the inductance of the return path, and instead of worrying about a loop. Because, ground looping will cause a bunch of noise, especially if you're into the high fidelity audio. It can be a really, really bad thing. But what they were talking about is the board-to-board connectors cause such an impedance because of the induction that they recommend just put as many ground and power supplies as you can. Okay, and so I did. We're going to give that a shot. Hopefully it'll pay off. We didn't really have any problems on the V3. I did, I think, run a bodge wire on the V3 between a couple of these guys. I don't remember. I'd have to go back and look at the video. And that was kind of basically just doing this right here. It was for the ground, I do remember. So yeah, that should eliminate it. And so for the people that are wondering, oh, should I wait to buy a V4 board versus a V3 board or controller? They're identical. The only difference that the V4 is going to give you is I don't have to put in a bodge wire, so it just saves me from having to add a bodge wire in there. But functionally, they function the same. Anyway, so yeah, I did that on both the high voltage boards. You can see I added and the button PCBs. So you can see like on this button header right here, everything's just going to ground. It looks like I changed probably for some more PCB routing to make the PCB routing a little better, easier. But yeah, there's no more disconnected pins. Oh, so button header 3 has nothing connected to it. It's there for mechanical stability. And so instead of just leaving them all disconnected like in version 3, I just tied them all to ground. All right. And that's just going to help with the return path. And that's it. That's it with the off-board headers. Okay. Okay, so let's see what else we have here. And this is the buzzer module. Nothing's changed on that. It's just a buzzer. That's what beeps. They call it a buzzer. I don't know why. I guess beeper doesn't sound right? Protection diode. I'm sorry. That's actually a bypass diode. Let's see. This is these are LEDs right here for the backlight. That's a little MOSFET that switches them on and off. Nothing is changed on this. I don't think. No. I remember I changed this C8 to a 10 microfarad, but I guess I did it in version 3. All right. So let's go look at the ADC. And there's been some changes on that. And the changes were because of LTC's recommendations. So we can kind of, I believe this is all, these are, oh, yeah, so here's kind of a big change, if you will. This is, if you remember on the version 3, and maybe I can put a picture up of the jumpers. Or if you have a controller, you can look in the manual and look at the jumpers. So previously in version 3 here, there was a jumper that went from, oh geez, I don't remember. Hold on, I'll have to look. Okay, I pulled up the user's manual. We'll go see if we can find that jumper here real quick. Let me make this a little smaller. Ah, here we go. Yeah, so this is to support 2-wire meat probes, okay? And 3-wire, sorry. 3-wire and 2-wire. Oh, no, that's right. 3-wire doesn't need the jumper. 2-wire needs the jumper, and 4 wires must have the jumper removed. Okay, is that confusing enough? Anyway, so yeah, and this was a bit how you doing. I knew it was in the beginning. I tried finding it something nice to go in there, and I didn't find anything I liked, so I ended up just making these things, and that was pretty ugly. So on the version 4, I added a regular header jumper, and you've seen these before if you've ever had to work on your PC. You pull these little jumpers off the header, like a 3-pin. This is a 3-pin male header, and you can move it between these two, or just pull it completely off. And I just put this right in front of this connector right here. So looking at the manual, that thing will go like right here, right? And when we look at the PCB, you'll see it in the next video. So that's what that is. So I added that to eliminate this this wire right here that looked pretty tacky. And let's see what else is in here. Oh yeah, so I added these. Now this is on the ADC reset line or pin, and it's a cap and a pull-up resistor, and this is to slow down the ADC reset, because what was happening, and by the way, when I show you the PCB, these are optional, and I actually have not installed them. So in other words, when I populate the PCB, I just leave these off, right? And it just acts like a normal reset line at that point. But if I add these, then this will of course stiffen the reset line, and this will slow it down. Right? So anyway, I leave these off. I've been leaving them off on the prototype V4 because I want to see if it's needed. And the reason why I put these in here is because when I was doing ESD testing, a pretty big zap seemed to reset the ADC. And I mean, which is, I mean, I don't know. I mean, it had to be zapped pretty good, right? Which is not really a problem. The controller just, it resets ADC and moves on, right? It doesn't affect your cook or anything like that, but I didn't like that. And so I put these in kind of as a test to see if I can stiffen that ADC reset line. And of course the V3 doesn't have that little test circuit. So and I'll when I do more ESD testing, I'll do a video. We'll talk about this and see if I can reproduce it on the version 4 PCB, on the version 4 board, when I'm doing the ESD zap testing. But since I changed the board from a 2-layer to a 4-layer, it might not happen. Okay, so anyway, these are optional, and I just added that circuit in there for testing. And let's see, what else did I do? Oh, yeah, so I did change some of the caps. This was because of LTCs. So the spec document, the LTC 2984 data sheet, calls for these 1 microfarad caps, right? And being a good doobie, I followed their suggestion, And then later saw that they changed their suggestion. And they basically just upped these to 10 microfarad and 1.1 microfarads. And I'm like, okay, so what I did on the version 3s is I just populated 10 microfarads in all these. And I didn't worry about the 0.1 microfarad. That worked pretty good. Actually, the 1 microfarad I didn't have any problems with. But see, it's all in the power supplies. If they're thinking this thing is going to take big gulps, and it's probably when you're doing some kind of, if you're doing a measurement that uses large amounts of current, they probably want bigger caps to support that. So I have not ran into any problems using the 1 microfarads. But I went ahead and populated the V3s with 10s. And then on the V4s, I just went ahead and added the extra 0.1 microfarads. I think it called for 1, 2, 3, 3 of them. Oh, 4 right here. Okay. So I changed that. And let's see here. SV out, 10 mic. Oh, so here's another one up here. And they also added this 1 ohm resistor. And the only thing I can think of is to keep it from resonating. I could not find why, they did that. So I went ahead and bought that silly thing, and I started just to leave it out. I bought that thing, and I guess I'll put it in there. I guess I should have contacted LTC and I guess it's not LTC anymore. It's Analog Devices. Anyway, I didn't contact Analog Devices to ask the engineers why that was in there. So I just went ahead and put it in there. And let's see what else we got. Oh, here's another. Now this one is where the version 4 might be a little better than the version 3. And that is, I added a nice 3.3 volt regulator dedicated to 2984 ADC. And that's just to help stabilize it. So any currents that are on the power rail for, like the ESP32 or something that's gulping power, this way it won't affect the operation of the ADC. And so I added that, and that actually wasn't in the LTC spec, but I added it because I wanted this thing nice and stable. Okay, so not that this one had really any problems, but I decided that that power is definitely, this thing needs nice, stable, clean power to get nice, stable, clean measurements, right? Okay, so what else do we got here? Yeah, see, there's that Q4. I don't remember what that means. I'll have to change that. Let's see. I don't know. These are all just bypass caps. Now that's changed. I think that's about it. Everything's the same. These are the protection resistors. Yep. I don't see anything else that's different. I did change the layout of it a little bit. It looks a lot different. That's just because I changed the way the lines. This actually is drawn the way they drew it in their recommendation. So I went ahead and just drew it like they did, and then so it's just changed a lot, right? I shouldn't say it hasn't changed. It hasn't changed much. It just looks different. That's what I meant to say. So yeah, that's all. The cold junction stuff's the same. That's it. That's those are the differences. As you can see, there's not many. I mean, the connection headers, yeah, There's hardly anything on this page except for the connection headers, and then there's the ADC changes. But like I said, I'd already started replacing these with 10 mics, so that didn't change. The 0.1 mics are probably help with the not to get into a bunch of theory, but yeah, these 10 mics will help with the bigger gulps, and these little mic, but they're frequency dependent. These have different frequencies, so this one will respond a lot faster to higher frequency gulps versus this guy right here, which will respond better to lower frequency ginormous gulps, if that makes sense. And if you watch the EEV blog, Dave Jones does a video talking about why you use different value caps on your power supplies. And he talks about the frequency and all that other stuff. And but yeah, he'll explain it a lot better than me. So yeah, anyway, that is it. So I hope you enjoyed this video. See you later. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.